Hi, this is Mr. Roix. As I mentioned, I was going to take you through these practice problems from the test review. So run through this real quick. First question is, what is the percentage of carbon in calcium carbonate? So first thing you need to do is you need to come up with what are the masses of each of these elements on the periodic table. Calcium has a mass of 40, carbon has a mass of 12, and oxygen has a mass of 16. Now in this particular case, calcium carbonate has 3 oxygens. So what you want is you want to multiply the oxygen by 3. So we multiply this by 3. So, and then we add them all together. So we have 40 plus 12 plus 48. So the total comes out to be 100. And we could refer to it as 100 grams of calcium carbonate. And it's asking what is the percentage of carbon in that. And I think I solved for calcium in class, now that I'm looking back at the problem. But percentage of carbon in calcium carbonate would be, well, there are 12 grams of carbon per 100 grams of calcium carbonate. And so the percentage, if we multiply that by 100, we would get an answer of 12% carbon. So it would be 12% carbon. Then it asks how much calcium carbonate can form if 0.22 grams of calcium react. So you can look that the ratio between the calcium and the calcium carbonate is a 40 to 100 or 4 to 10 ratio, but it's basically 40% calcium. So again, you can put it into ratios, but I would set it up like this, where I'd say if I have 0.22 grams of calcium, right, for every 40 grams of calcium, I would have 100 grams of calcium carbonate. And then so what ends up happening is the grams of calcium cancel grams of calcium, and you multiply this through, and you end up with an answer of 0.55 grams of calcium carbonate. So, and again, if you set it up in a ratio, you would be using these same values that I used there. Okay, next question, what is the percentage of oxygen in KMnO4? So again, we need to come up with the masses of each of these. So K is 39.0 grams. Mn, manganese, is going to be rounded. We could round up to 55 grams. And then oxygen is 16, and we multiply that by 4, and we end up with 64. So then we add these all together. When we add them all together, we end up with 158 as a total, 158 grams. Percentage of oxygen, so we do 64 divided by 158, and we would get an answer of 0.405, or multiplied by 100, 40.5% oxygen in KMnO4. Next question. Okay, so the next one, what is the percentage of iron in Fe3O4? So again, we're going to do the same thing. We're going to say Fe. We'll look up that mass on the periodic table, and that is 55.8. We can round up to 56. Oxygen is 16. Then we multiply them by the numbers. So Fe is 3, oxygen is 4. So this is going to come out to 168 for the Fe. It's going to be 164 for the, or not 164, 64 for the oxygen. Add those two together, and we get an answer of 232 grams. And so if we want to know the percent iron in there, we would take the 168 divided by 232. So if you divide 168 by 232, you get an answer of 0.724 multiplied by 100, and the percent iron in Fe3O4 is 72.4%. Now it asks how much iron can be obtained from 100 grams of Fe3O4. So again, we can use these values that we have over here as ratios or conversion factors. I like to refer to them as conversion factors. And we can say if we start with 100 grams of Fe3O4, sorry, I guess that means the end of the day, then we could say for every 168 grams of iron, there are 232 grams of Fe3O4. So if we multiply that value out, we will get an answer of 72.4 grams of Fe. So that's the first part of the worksheet. I will post the rest of this shortly.